Hello guys, how are you today? So today I'll be explaining the AP Chemistry quiz. This quiz is CT102. So you can find this on the AP Classroom. Of course, I'm going to be using the answer key. And very simply, let's get started. A loose diagram for the molecule C2H4 is shown above. In the actual C2H4 molecule, the HCH bond angles are closest to. So this is the diagram for the molecule C2H4. They said the HCH like this. It's either this one or this one, right? They're telling us, what about these? What is the closest angle for them? Well, very simply, you will just choose one of the carbons to be the central atom. For example, I chose this one to be my central atom. Then I see, surrounding it, what do I have? I have 1, 2, 3 atoms. So my central atom is A, and everything surrounding is X, so that's AX3. And then what do I have remaining? I need to check if I have any lone pairs. So no, I don't have any lone pairs. If I don't have any lone pairs, then I will directly say that خلاص, my finalized shape is what is AX3. So AX3, if you check, its shape is gonna be what? It's gonna be a trigonal pyramidal. Trigonal planar, my bad. It's gonna be a trigonal planar. And in the trigonal planar, all of the angles are 120 degrees. So the approximate angle is gonna be what? It's gonna be approximately 120 degrees. Now we will move on to question 2. What does it say? It says, answer the following questions using principles of chemical bonding and molecular structure. Consider the carbon dioxide molecule CO2 and the carbonate ion CO3 2-. They said, draw the complete loose electron dot structure for each species. So we need to draw the loose structure for, first of all, CO2 and for CO3 2-. Now, basically for this, you don't need to take into consideration the resonating structure, okay? But as long as you draw what? You draw CO2. So how do we draw CO2? Let me just make the size a bit smaller over here. So we're going to have C as our central atom, right? And then surrounding it, we have oxygen and oxygen, okay? Now, carbon is in group 4 plus oxygen is in group 6. So 4 plus 6 times 2, that's going to be 16. Then we will subtract from it what? We'll subtract from it 4 because we have 2 bonded pairs. 16 minus 4 is what? It is 12. Then 12 divided by 2, this will give us what? This will give us 6 lone pairs. So I need to put 1, 2, 3, 4, 5, and 6 first on the surrounding atoms. Now we check, do they all fill the octet? No. So what do? We take from here the lone pair, we turn it into a double bond, and we take from here the lone pair and we turn it into a double bond, and this is what? This is the loose structure of CO2. Now for carbonate, okay, yeah, I think I'm gonna erase, so please save this, write it on the copybook. This is the loose structure of CO2. For the carbonate ion, we'll start with carbon, and then we have 3 surrounding oxygen. Now, carbon is group 4, oxygen is group 6, so 6 times 3, and don't forget, 2- means we have 2 extra electrons, so we will add 2. So 4 plus 6 times 3 plus 2, that's going to be 24. 24 minus 6, because we have 3 bonded pairs, that's going to give us 18. 18 divided by 2, that's going to be 9. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now we see, do all atoms complete the octet? No. So very simply, to make it complete the octet, we erase, for example, this one, and we will turn it into what? We will turn it into a double bond. Now, resonating structure does not apply in this question, okay? So please have them taken down. Now they said that account for the fact that the carbon-oxygen bond length in CO3 2- is greater than the carbon-oxygen bond length in CO2, right? They want us to explain why. So they want us to explain why. So if we go back to our structure, we would see what? We would see that carbon dioxide has what? Has double bonds. So we can say that carbon dioxide, CO2, has interactions as double bonds. Okay? Now, in addition to that, what do we have to also say? We will say that in CO3 2-, the carbonate ion, the interactions are resonating. So interactions are resonating. Now, what does it mean that the interactions are resonating? It means that they can change form. So very simply, from all of this, we can state that the carbon-oxygen bond length is greater in resonance than double bonds, okay? So very simply here, this is literally all we need to say to get the marks. You just need to say CO2 has interaction as double bond, CO3 has interaction as resonating, and the carbon-oxygen bond length is greater in a resonance than in a double bond, okay? So that's it for double I. Okay, let me just erase these. So now, what does it say in part B? Draw the complete loose electron dot structure of each molecule, CF4 and SF4. Okay, so we first start with CF4. C is the central atom, and then we have FFF. C is group 4 plus 4 times 7. How much is that going to be? 4 plus 4 times 7. That's going to be 32. We'll subtract from it 8 because we have 4 bond pairs. So that's going to be 24 divided by 2, which is what? Which is 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Now we check, does everything complete the octet? Yes, so this is the final form of CF4. Now we'll move on to the next one, which is SF4. S is the central atom. F, 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 F. S is group 6, okay? Plus F is group 7, so 6 plus 4 times 7. What's that gonna be? That's gonna be 34. Subtract from it 8 because we have 4 bonded pairs already, so 26 divided by 2, that's gonna be 13. So we will have 13, so it's gonna be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now where do we put the final lone pair? We will put it on the central atom, okay? So this is the structure for SF4. Now, they're telling us, in terms of the molecular geometry, so let's talk about the molecular geometry. We know that CF4 has which shape? CF4 has the shape of AX4, whereas SF4 has the shape of AX4E. Now, the shape of AX4, it is what it is, a tetrahedron. And the shape of AX4E, it is what it is, a trigonal pyramidal. So here it is what it is, a trigonal pyramidal. Now these are the geometries of whatever we have in front of us. They want us to compare or account for the fact that CF4 is non-polar, whereas SF4 is polar. Very simply, how can we state this? Well, first of all, we say that CF4 has a what? It has a symmetrical shape. This is the first thing we start with. And SF4 has what? Has an asymmetrical shape. This is the first thing that we can say, right? So due to the symmetrical shape that CF4 has, which is the tetrahedral geometry, the bond dipoles cancel. So here we say bond dipoles cancel, right? And when these bond dipoles cancel, we will thus have what? We will thus have a non-polar molecule. Non-polar molecule. Now, this is under the condition that all of the atoms are the same surrounding the central atom. So this is true. First condition, it's a symmetrical shape. Second condition, all of the atoms are the same elements. So the bond dipoles cancel and we will have a non-polar molecule. Whereas in SF4, it has a trigonal bipyramidal electronic geometry. So due to this, the bonds do not cancel. So dipole bonds do not cancel. So then it's gonna be what? It's gonna be polar, okay? So that is it for question number 2, okay? Basically, that's what you need to write. Of course, you need to write it in a paragraph sentence form. And when you do it like that, you will get what? You will get the full answer. Now, we'll move on to question number 3. Question number 3 is long. I think the only long parts in the quiz are the written parts, which are this. What does it say? It says, non-metal formula of compound. Some binary compounds that form between fluorine and various non-metals are listed in the table above. A student examines the data in the table and possesses and poses the following hypothesis. The number of fluorine atoms that will bond to a non-metal is always equal to 8 minus the valence electrons in the non-metal atom. So, very simply, based on the student's hypothesis, what should be the formula for the compound that forms between fluorine and chlorine? What did they say? He said that to find the number of F atoms that will bond to a non-metal, it's always 8 minus the number of valence electrons. So fluorine bonds to chlorine. Chlorine is which group? Group 7, meaning it has 7 valence electrons. If that's the scenario, it's going to be 8 minus 7. So it's going to be 1, right? So we will have 1 fluorine bonded to chlorine. So it's going to be ClF. Okay? In part B, what does it say? It says, in an attempt to verify the hypothesis, the student researches the fluoride compounds of other halogens and finds the formula ClF3. In the box below, draw a complete loose electron dot diagram of ClF3. So let us draw it. We have Cl as the central atom, and we will have F here, F here, F here. Cl is group 7, and F is also group 7. So it's going to be 7 plus 3 times 7. That's going to be 28, right? We will subtract from it 6 because we have 3 bonded pairs. So that's going to be 22 divided by 2. That's going to be 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So this is what it looks like. And what is the geometry of this structure? It is AX3, E2, and usually this is usually T-shaped. Now, 2 possible geometric shapes for this are either trigonal, planar, and T-shaped. The student does some research and learns that the molecule has a dipole moment. Which of the 2 shapes is consistent with the fact that ClF3 molecule has a dipole moment? Justify your answers in terms of bond, polarity, and molecular structure. Okay, so very simply, we need to compare between trigonal planar, which is for AX3, and T-shaped, which is for AX3-2. They're telling us, why is it T-shaped and not trigonal planar? Very simply, because trigonal planar is what is asymmetrical, right? And we said in asymmetrical, it will, the dipoles cancel, right? Dipoles cancel, and then it will end up being what? It will end up being having no net moment, no dipole moment, right? And due to this, what can we say? We will say that it is what? That it will be a non-polar molecule. Whereas here, they told us that it's a dipole moment. If it's a dipole moment, that means this is what? This is a polar molecule. It has a polarity. If it's polar, it definitely cannot be symmetrical. So that's why we chose what we chose, the T-shaped. Okay, so that's it for this question. What does it say? It says, in an attempt to resolve the existence of ClF3 molecule with the hypothesis stated above, the student researches the compounds that form between halogens and assembles the following list. Based on the concepts of atomic structure and periodicity, propose a modification to the student's previous hypothesis to account for the compounds that form between halogens and fluorine. Okay, so basically he found out that it can be what? It can be ClF and ClF3 only here. So we will not take into consideration about F. We will not really care about it. We'll focus on the rest. They told us to make our own hypothesis. From this, we can see what? We can see that, first of all, we have 1F, 3F, 1F, 3F, 5F, 1, 3, 5, 7. These are all what? These are all odd numbers. So we should say that the atomic structure always contains odd number of F. So 4 halogens, the atomic structure always contains odd numbers of fluorine, right? What do we also notice? We notice that when we go down, as we go down the group, the number of fluorine that can be bonded increases. So what do we call this? We say that as the atomic number increases, the number of fluorine increases. So we can say as the atomic number increases, the number of fluorine increases, very simply. Okay, so that's question number 3 finished. I think from 2 till 6, they're the only hard and long ones. Everything else is easy and quick to solve. Answer the following questions by using principles of molecular structure and intermolecular forces. Structures of the pyridine molecule and the benzene molecule are shown below. Pyridine is soluble in water, whereas benzene is not soluble in water. Account for the difference in solubility. They're saying why does pyridine dissolve in water, whereas benzene does not. Okay, so for this one, we have to first of all identify the structural difference. The first structural difference we notice is that pyridine has nitrogen, right? So we will say pyridine has a nitrogen with a lone pair, right? Instead of the CH in benzene. So this is the first thing that we state. We first state that pyridine has a nitrogen with a lone pair instead of or in place of the CH in benzene. Now, the second thing we notice is that, first of all, what does it mean when we have a nitrogen with a lone pair? This means that it's one of the very electronegative atoms, right? And that means it will form what? It will form a hydrogen bond, because the only 3 that form a hydrogen bond are fluorine, oxygen, and nitrogen. So pyridine has a nitrogen with a lone pair instead of the CH in benzene. Then we say that the nitrogen with lone pair in pyridine forms what? It forms a hydrogen bond. Or we can say that pyridine forms a hydrogen bond, right? With water, while benzene cannot, right? So because of this, now what do we also notice? If we cut this in the center, we will see that it's not symmetrical, whereas if we cut this one in the center, we will see that it's symmetrical. If it is symmetrical and all of the atoms surrounding are the same, then it's directly what? It's directly a non-polar. So we will say now, the third thing we're gonna state is that, I think I'm gonna write it on the side. I will write it over here. Pyridine is a polar molecule, right? And benzene is a non-polar molecule. Okay, and we already stated that pyridine has a hydrogen bond with water while benzene cannot. So now pyridine will dissolve in water. So pyridine dissolves in water because of the hydrogen bond, because of H bond. Benzene forces are too weak. I spelled weak wrong. Are too weak. So it is insoluble. Okay, this is part A. We'll move on to part B. What does it say? In part B, it says, so structures of the dimethyl ether molecule and the ethanol molecule are shown below. The normal boiling point of dimethyl ether is 250 Kelvin, whereas that of the ethanol is 351 Kelvin. Account for the difference in boiling points. You must discuss both substances in your answer. So what we need to do now is we need to compare the forces of dimethyl ether and ethanol. So of course, whatever I write, you need to write it in paragraph form. But very simply, what we can state first of all is the forces in dimethyl, my bad. Dimethyl ether. Okay? What are the forces found in dimethyl ether? It only consists of 2 forces, okay? The very first force it consists of is the LDF, which is the instantaneous dipole-induced dipole, okay? Because, of course, all molecules have that. Now, the second thing it has is what is very weak, because this is considered what? It's considered almost a non-polar, okay, because like it cancels out, but because it has weak dipole, it's a little bit polar, okay? So forces in dimethyl ether, what do we have? We have LDF, which is the instantaneous dipole-induced dipole, and then it also has weak dipole interactions, okay? Now, this is for what? This is for dimethyl ether. Now, ethanol, what are the forces found in ethanol? Again, you have to write this in a paragraph form. Ethanol has what? It has LDF, it has weak dipole forces, and it has a hydrogen bond. How do we know? Here, this cannot form a hydrogen bond because it's literally, as we said, it has weak dipole forces, but in some sense, it's what? It's non-polar because it's symmetrical and everything around it is the same. So it should not be able to form a hydrogen bond because it's what? It's non-polar. Whereas over here, it's very polar because it's asymmetrical, right? And the oxygen, being one of the three very electronegative atoms, will form a hydrogen bond. So that's why it also has a hydrogen bond. Next thing we say is what? Is hydrogen bond are strong forces, are strong intermolecular forces, are strong intermolecular forces, right? So they require more energy to break bonds. Okay? So thus boiling point will be higher. Okay? So then we can say, so thus the boiling point of ethanol will be higher. So in summary, forces in dimethyl ether are LDF and weak dipole. Ethanol is LDF, DP, and hydrogen bond. This hydrogen bond is a strong intermolecular force, so it needs more energy. And due to the need of more energy, it needs more energy to break bonds, and due to the need of more energy, it will need a higher temperature, which is what? Which is a higher boiling point. We finished from part B. We'll move on to part C. What does it say? In part C, it says SO2 melts at 201 Kelvin and SiO2 melts at this much. Now, account for the difference. First thing, we need to discuss what are the forces. My bad, I don't know what happened. Let me undo that. Okay. So SO2, what are the forces that we find in SO2? First of all, SO2. If you were to draw its structure, it would be an asymmetrical molecule, right? So that means it's definitely polar. If it's polar, it's gonna have the permanent dipole, and including that, everything has the LDF forces. Now, even though it has oxygen does not form a hydrogen bond because there's no hydrogen here that we are talking about. So if there was a hydrogen, we would state hydrogen bond. But there's no hydrogen, so we don't state hydrogen bond, okay? Now, next thing, SiO2, okay? SiO2 is what? It's a covalent network solid, so it has what forces in between? It has covalent forces in between, right? So these covalent forces or these covalent bonds must be broken for SiO2 to melt. So due to this, covalent bonds are much stronger than dipole forces. So thus we can say covalent bonds need a lot of energy to overcome. So need a lot of energy to break, Thus, this is why boiling point is increasing. Or sorry, we're talking about melting point. So this is why the melting point increases. Now, of course, everything I just said, you need to write it in a paragraph form. We'll move on to part D. What does it say? It says the normal boiling point of Cl2 is 238 Kelvin. And it's higher than the normal boiling point of HCl. Why exactly? This is a very important question. First of all, we take Cl2 and HCl. Here's HCl and here is Cl2. Now, looking at this, if we drew Cl single bond Cl and H single bond Cl, we will see first of all that this Cl will share the electron equally, so it's what? It's non-polar. And over here, the HCl if you follow the Falkland-Bridge rule, right, what will we see? We will see that hydrogen is less electronegative than chlorine, so chlorine is more likely to attract the electron, so it's gonna be what? It's gonna be polar. Now from this we can say that this has a dipole, right? And over here this has LDF, and this also has LDF. But however, okay, when it comes only to the point where we are discussing dipole and LDF, right? And there is no mention of a hydrogen bond, we will go back to what? To the LDF. Now we need to compare these two molecules, Cl2 and HCl, based on their London dispersion forces. Now, we know that based on the London dispersion forces, the more electrons we have, okay, I'm just gonna write it over here, more electrons increases the electron cloud. When the electron cloud increases, what does this mean? That means it's more polarizable, right? And the more polarizable it is, the stronger the ID force is. So if you compare the number of electrons here to the number of electrons here, this is gonna be our winner. So this is why Cl2 has a higher boiling point than HCl. Okay, so how would you say it in a paragraph? You will say that Cl2 has London dispersion forces, HCl is a polar molecule, so it has dipole, and London dispersion forces. Now, London dispersion forces depends on the number of electrons, so the more electrons we have, it will increase the electron cloud, and the greater the electron cloud, the more polarizable it is. That means the stronger the forces are. The stronger the forces are, the more energy is needed, and the more energy needed, it means what? It means that the boiling point is gonna increase. So this is what we're gonna say, and then we will state that chlorine, Cl2, has more electrons than HCl. And yeah, that's it for this question over here. Now we'll move on to question number 5. What does it say in question number 5? It says, okay, so compound name, compound formula, and delta H. Propane, CH3CH2CH3, 19, propanoane, CH3COCH332, and propanol, CH3CH2CH2OH, and that's 47.3. Now, using the information in the table above, answer the following questions about organic compounds. For propane, draw the complete structural formula of propane. Propane is gonna be like this. It's gonna be C, right? Because propane means we have 3 carbons in the middle. Then here we have H. Oh, sorry, they said propanoane. My bad, I was drawing propane. Propanoane. So it's still correct, okay? So HHH. Then we have what? We have O. So we have a double bond over here because O always forms a double bond. So double bond O. And then what we have on the other side, we have H, and H. So this over here is what is the propanone. So if you draw the structure, this is what the propanone looked like. Now they told us to predict the approximate carbon-to-carbon bond angle. So what do they mean by carbon-to-carbon bond angle? They mean very simple. They want one carbon that is attached to what? That's attached to 2 carbons, because it's carbon-to-carbon-to-carbon. That means one carbon attached to 2 carbons. So it's definitely what? It's definitely the central carbon. Now you take the central carbon and you see that it's attached to 1, 2, 3 atoms, right? So it's gonna be AX3, and there is no lone pairs. So if there are no lone pairs, then what do we say in this scenario? We say that this is gonna be a trigonal planar. And a trigonal planar has an angle of 120 degrees, okay? So this is for AI and II. We move on to part B. What does it say? It says, for each pair of compounds below, explain why they do not have the same value for their standard heat of vaporization. For propane and propanone, propanone. So propane and propanone, why do they not have the same delta H? Now, what did we say? We said, remember, anytime it is what? It is only carbon and hydrogen, then directly it's what? It's non-polar. Anytime it's carbon and hydrogen, it's directly non-polar, okay? So, That means propane is non-polar and propanoane is what is polar. Okay? Because as you can see, the oxygen is what makes it polar. Because look, as you can see, we're talking about this carbon as the central atom, right? So let's say that we have the polarization coming from here, polarization coming from here, and polarization coming from here. These will cancel each other out, but there's still a polarization coming from the oxygen. So this is why it is polar, even though it is symmetrical. Yes, it is symmetrical, but the atoms surrounding the central atom are not all the same. So that's why it's polar. So first of all, if it's non-polar, then the only force it will have is the London dispersion force. And if it's polar, it will have the dipole and the London dispersion force. And for sure, since both of them have different types of forces, this is why, so they did not tell us to specify if it's higher or not. They just told us why they don't have the same value. So you're just going to explain they don't have the same value because they have different forces. Now, propanoane and 1-propanol. Now, we said because propanoane is symmetrical, the oxygen cannot form a hydrogen bond. This is one thing for sure. Because it's symmetrical, oxygen cannot form a hydrogen bond. Now, 1-propanol is asymmetrical. So directly the oxygen forms what it forms, a hydrogen bond. And the dipole and the London dispersion forces. So definitely for sure, because it has two different forces, which is the hydrogen bond and the dipole forces, then for sure we will say that they will have different enthalpy of vaporization. Now, part C, draw the complete structural formula for an isomer of the molecule you drew in part A. In part A, what was the structure we drew? This is the structure that we drew. They want us to draw what? They want us to draw an isomer. So we can draw an isomer by doing what? By moving the functional group, which is the double bond O, right? So if we did end up moving it, I think this is a lot like AS, it would be like this, right? So this would be our carbon and it will have the functional group. Okay, now we need to make sure that every carbon has 4 bonds. If it does not have 4 bonds, you will replace it with a hydrogen. So hydrogen, 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 and hydrogen. So this is what over here? This is the isomer. Now, we go down. What does it say in part D? It says, give the structural formula for propene below. Oh, there's part I and, given the structural formula for propene below, there's part I and double I. Indicate the hybridization of the carbon atom, indicated by the arrow. So this over here, what do we have? We only have 1 atom here and 1 atom here. So because it is what? It is AX2 and there are no lone pairs, then directly we say this is what we say, that this is sp hybridized. Okay? Now, part 2. What does it say? Indicate the total number of sigma and pi bonds on the molecule. So sigma is gonna be single bond, 1, 2, 3, 4, 5. Okay, and then you take the bottom one from this, so 6 sigma bonds. So we have 6 sigma bonds. And then we have 1, 2, so we will also have 2 pi bonds. So that's it for this question. Now this is the last written question, I believe. Anyways, this is the last question that requires a lot of talking. Use the information in the table below to respond to the statements and questions that follow. Your answers should be in terms of principles of molecular structure and intermolecular forces. Okay, they said in part A, complete the Lewis structure in the appropriate style of what? Of ethine. We need to complete the Lewis structure of ethine. So do you see how they drew everything? We need to draw it similarly. So ethine means we have, let's just draw the regular Lewis structure. C, H, C, H, right? Now, how many carbons do we have? We have 2 carbons, so 2 times 4 plus 2 times 1, which is 2. So 2 times 4 plus 2, that's gonna be 10. 10, subtract from it 1, 2, 3, 6. We are left with 4. Divided by 2, that's what? 2 lone pairs. And remember that hydrogen never gets a lone pair. So what will take the lone pair? The carbon. We'll have a carbon over here taking this lone pair and this lone pair as well. Now you need to check if everything completes the octet and duplet. Hydrogens have their duplet complete, but carbons do not. So to complete the octet, we will turn these into what? We will turn these into a triple bond, so it will look like this. Now to draw it the same way they drew it, we will do it like this. What did I do? My bad. I have no clue what I did. H, then the single bond, which is 2 electrons. Then C, we have a triple bond, that means it's 6 electrons, right? And then we have another C, which has what? A single bond with H, so this is what it looks like. Anyways, we'll move on to part B. What does it say? It says, which of the 4 molecules contains the shortest carbon-to-carbon bond? Now, usually the shortest bonds are the ones that have the highest order number. So 1 has the longest bond, then 2 has a shorter bond, then 3 has the shortest bond. So out of all of them, you need to look for one with the highest bond order or the highest bond number. So in this case, it's gonna be what? It's gonna be ethyne. If they asked you to explain, they did ask us, you will say ethyne because it has a triple bond. Okay, will have the shortest carbon-to-carbon molecule. Okay, so you will say, due to ethyne having a triple bond, it has the shortest carbon-to-carbon bond. Okay, so that's it for B. We'll move on to C. What does it say in C? In C, it says, a Lewis dot diagram of a molecule of ethanoic acid is given below. The carbon atom in the molecule are labeled X and Y respectively. Okay? They said in carbon part I, identify the geometry of the arrangement of atoms bonded to each of the following. First of all, they want the geometry from carbon X. So take carbon X as your central atom, that's A. It has 1, 2, 3 surrounding, right? It has 3 surrounding. So it's gonna be what? It's gonna be AX3, and there are no lone pairs, so it's gonna be AX3. And what's the shape of AX3? This is gonna be a trigonal planar. So the geometry of AX3 is what? Is a trigonal planar. Now the second one, which is double I, which is carbon Y. So let's take this carbon as the central axis. It has 1, 2, 3, 4. So this is AX4. No lone pairs. So this is gonna be what? It's gonna be a tetrahedral. Now we finished from part C. We'll move on to part D. What does it say? It says energy is required to boil ethanol bonds. Consider the statement as ethanol boils, and energy goes into breaking carbon-carbon bond, and then carbon-hydrogen bond, and then carbon-oxygen bond, and then oxygen-hydrogen bond. Is the statement true or false? Justify your answer. Okay, now this may look like a complicated question, but it's only a trick question. They said it's required to boil ethanol. When we say boil ethanol, we are changing states. And we said whenever we are changing the states, we don't do anything with breaking the bonds, like breaking the intramolecular bonds, because this is in the bond. It's carbon-carbon bond, because look here, carbon-carbon bond, carbon-hydrogen bonds, carbon-oxygen bond, and oxygen-hydrogen bond. So these are intramolecular. Whatever they're describing is intramolecular, and we only break the intramolecular bonds whenever we are doing what? Whenever we are decomposing. But in this scenario, we are not decomposing, we are changing the state. Okay, so whenever we change the state, we focus on the intermolecular bonds. So this statement is false. They told you to say this statement is false. Yes, this statement is false because all of these, as all bonds described, are molecular, and are not broken during vaporization. Okay, so that is it for part D. We'll now move on to part E. What does it say in part E? In part E, it says, identify a compound from the table above that is non-polar and justify your answer. So let's go back to the table above. Which of these compounds is non-polar and why? Okay, so directly we look at ethane and ethyne. First of all, because they are hydrocarbons, we directly say they are what? They are non-polar. Both of these are directly what? They are directly non-polar because they're only hydrocarbons. Only hydrogen, only carbon. Okay? Now, they want us to go further into detail. You can say that it is non-polar because it's either symmetrical. You can either say that because they are both symmetrical, they are both non-polar, or you could say because the bond dipoles cancel each other. Whoops, my bad. So you can say what? You can say that here. So you can say that the bond dipoles cancel each other. Okay, so you either say that they're non-polar because they're symmetrical, or you say that they're non-polar because the bond dipoles cancel each other. So I'm just gonna write an answer here. Non-polar because, sorry, what did we say? We said ethane or ethine. They are non-polar because they are symmetrical, or the dipoles cancel each other. Okay, perfect. Now we'll move on to part F. What does it say in part F? Ethanol is completely soluble in water, whereas ethanethiol has limited solubility in water. Account for the difference in solubilities between the two compounds in terms of intermolecular force. So if we go up and we state the intermolecular forces that we find in ethanol, okay, and ethanethiol, okay? So you directly think of the strongest bond you have over here, which is definitely the hydrogen bond. It's asymmetrical, first of all, and it has oxygen, which is a high electronegativity, so hydrogen bond. Now here, it's asymmetrical, so for sure it's gonna have what? It's gonna have a dipole, okay? So this is gonna have dipole. Now, why is ethanol soluble in water, whereas ethanethiol, whatever it's called, I can't say it, is insoluble in water? First of all, we said ethanol forms strong hydrogen bonds with water, but this cannot form hydrogen bonds. The ability to form hydrogen bonds will increase the attraction between molecules of ethanol and molecules of water, making them more soluble in water. So to write our answer over here, I'm going to write it in here. We can say that ethanol forms hydrogen bonds with water, unlike where is it? My bad. Unlike this thing that I cannot say its name, okay? So thus, the hydrogen bond increases attraction between molecules of water and molecules of ethanol. Okay, so thus it is soluble. Okay, so that's it for all of the written parts. Now we go to the nicer parts, which are in my opinion much better, which is these parts over here. So we start with this one over here. Consider the molecules represented above and the data on the table below. So what do they want us? They said nonane and 2,3,4 trifluorane pentane, trifluoropentane have almost identical molar masses, but nonane has a significantly higher boiling point. Why does nonane have a significantly higher boiling point? If you check the structure for nonane and 2,3,4 trifluoroethane, you will directly see that nonane has a longer chain structure than 2,3,4 trifluoroethane. Now, because it has a longer chain structure, it will have thus a boiling point. Why? Due to more contact places or more contact for the forces. Okay, so the more linear or the greater the chain, oh sorry, this is the wrong one. The greater the chain, the longer the chain, then the higher the boiling point. Okay. For this one over here, they told us to make AU stronger and harder, it's often alloyed with other metals such as Cu and Ag. Consider two alloys, one of Au, Cu, and Au, Ag. They told us if the AuCu alloy Okay. If the AuCu alloy is harder than the AuAg alloy, which of the following is the best explanation? First of all, we look at the metallic radius. They have almost similar metallic radius. And the melting point, you will see that Ag has kind of a lower melting point than Cu. Now we go to oxidation and we take the highest oxidation state. Ag is always +1 the highest and Cu is 2 plus the highest. So definitely, with it having with it having a greater charge, and this charge is positive, so the more positive the charge is, the smaller the atomic radius or the metallic radius. So Cu and Ag don't have similar metallic radius, my bad. They have Cu having a shorter metallic radius. Now, if Cu has a shorter metallic radius, then the electrons of Cu are gonna be closer to the nucleus of Au. So we can say that Cu will then have a smaller atomic radius than Ag, so they will interfere more with the displacement of atoms in the alloy. So it all has to do with the smaller atomic radius, okay? Or the smaller metallic radius. We'll move on to the next one. They said, what's the hybridization of this molecule above? Very simply, what do? We take one of the carbons, okay? They want the hybridization of the carbon atom. So you take one of the carbon and you say, okay, surrounding the carbon atom, I have only 2 and I don't have any lone pairs. So this is AX2. AX2 is linear and it has an sp hybridization. That means the hybridization here is what is sp. We'll move on to question number 10. What does it say in question number 10? So, of the following organic compounds, which is the least soluble in water? Directly, when you see least soluble in water, you need to think which ones of these has the weakest forces, okay? So this one, looking at it directly, you see that it has a hydrogen bond because it's asymmetrical and it has oxygen. This is also asymmetrical and it has oxygen, so it has a hydrogen bond. This as well is asymmetrical and it has oxygen, so it has a hydrogen bond. So all 3 of these have a hydrogen bond, except for this one. It does not have oxygen, it does not have fluorine, it does not have nitrogen. So for sure, this is gonna be the least soluble in water. We'll move on to question 11 to 13. So they want the molecule out of these options that has a trigonal pyramidal geometry, okay? So because 11, 12, and 13 need the same structures, I'm going to draw them once and we will use them always. So carbon dioxide. Okay, so I'm just going to draw them very quickly so we don't waste any time. So this is what? This is CO2. This is H2O. C2H4 looks like this. And then pH3 looks like this, okay? So these are the 4 structures directly. So anyways, they want the one that has a trigonal pyramidal geometry. Over here, this is what? This is AX2. Actually, only AX2 because it's a single carbon with 2 surrounding electrons and no lone pairs. This over here is going to be AX2E2. This over here is, if you choose this one over here, you will have 1, 2, and 3. So the central atom is bonded to 3 atoms, but no lone pair, so it's AX3, and this is AX3E. Now what do they need? They want trigonal pyramidal. This over here is linear. This over here is bent, V-shaped. This over here is trigonal planar. And last but not planar. And last but not least, we have AX3E, which is the trigonal pyramidal. So just like that, we choose what? We choose pH3 as our answer. Now we'll move on to the next one. They said they want a molecule with only 1 double bond. So we will go up and we will find the molecule with only 1 double bond, which is the C4H2. Then they want what? They want the molecule with the largest dipole moment. Directly, when you think of largest dipole moment, you think of delta En, and you think of the ones with the highest electronegativity. So the highest electronegativity are fluorine, oxygen, nitrogen. So or you could follow the Falkland-Brish. Okay? Now, carbon and oxygen, it works out. However, oxygen and hydrogen are farther than each other, so they have a larger dipole moment. Carbon and hydrogen are close. Phosphorus is not here, so we will not include it. So, which is the answer? The answer is gonna be H2O. That's 13. We'll now move on to 14. Which of the following molecules are resonance structures necessary to describe bonding satisfactory? Yeah. What we do in this scenario is we need to draw all of the structures. So CO2, if you draw it, it's gonna be like this. SO2, if you did draw it, it would look like this. Okay. OF2. OF2 looks like this. Oxygen, fluorine, fluorine. And then here, this one. Okay, and then oxygen here and here. And then the last one is PF3. I'm doing them quickly because I have the answers already. You guys need to practice on the answers, okay? So PF3 looks like this. P, F, F, F. Okay, so they want the one where it has a resonating structure. Directly, you cross out anything that does not have a double bond. So you cross this one out. Bye-bye. Now you're left with these two. Resonating structure means that the bond can change its place. Here, the bond, if it changes its place, it doesn't matter. It's like as if it did not change. So we cross this one out. This one, if you change the place of the bond, yes, it will matter because it will change the entire structure, okay? So this is the resonating structure. Now we'll move on to question number 15. What does it say in question number 15? Which of the following molecules has an angular bent geometry? That's commonly presented resonance. So very simply, CO2, we know how it looks like. It's like this, right? Now, O3, how does O3 look like? I'm just gonna check really quickly. O3 looks like this. O. Yeah, like this. Okay, this is how O3 looks like. Now, BeF2, it's, if I'm not mistaken, it's a linear structure because it will look like this. Be, F, F, right? Okay, so it's a linear structure. And then the last thing we have is OF2. And OF2 is like this. It's O, 2 bond here. The 2 lone pairs. And then the rest of the lone pairs on fluorine. So I just drew the structures really quickly. You guys should draw the structures. You should know how to draw them by now. Anyways, what do they want? They want that has an angular bent geometry. So you cross out anything, these two, because they're not angular. The only angular ones are these two. And they said the resonance hybrid, so you will remove this one because it's not a resonating structure, but this one is a resonating structure. That means the correct answer is what is BO3. We'll move on to question number 16. Of the following molecules, which has the largest dipole moment? Of course, you have to remember Falkland-Brish. Okay? And you need to compare. You need to see, okay, carbon and oxygen, that's far. Then carbon and oxygen again. Okay, then hydrogen and fluorine, that's very far. This is the farthest, so for sure I'm going to choose it. F2, no, because F and F, they will share the electron equally, so it will become non-polar. Even in CO2, by the way, if you drew it again, I don't know how many times we drew CO2 already, but if you draw it and you will see that it's going from C to O and C to O, you will see that they will cancel out. So this is why HF has the largest dipole moment. We'll move on to the next one, which is 17. The best explanation for the fact that diamond is extremely hard. When we think of diamond, we directly think that it has strong covalent bonds. So this is why this is the correct answer. We'll move on to question number 18. According to the VSEPR model, the progressive decrease in the bond angles in the series of molecules CH4, NH3, and H2O is best accounted for. Basically, they're saying CH4. It looks like this, CH4. Then NH3, which looks like this. H, okay? And then H2O, which looks like this, right? Now what do you notice? Here we have no lone pairs, here we have one lone pair, here we have two lone pairs. So it's the increasing number of shared pairs of electron. This is what's causing the decrease in the bond angle, because the lone pair will push away the bonds more than the bonds push the bonds, okay? So we move on to question number 19. Which of the following would have two unshared pairs of electron on the central atom? You will draw them. This is H, single bond, C, triple bond, N, and you have one single bond, one lone pair over here. Carbon dioxide, we drew it like 50 million times. If you don't know how to draw carbon dioxide, it's going to be very upsetting because they made us do it so many times. Then we have an H3, like this. And then we have H2S, which is what? Which is like this. So which one of them has two pairs of electrons on the central atom, like unshared electron? It's going to definitely be A, which is H2S. Now, which of the following is a molecule that contains polar bonds? Pay attention. Polar bonds. And it's what? It's a non-polar molecule. Okay? So first thing you see, ammonia. NH3. Do you remember the shape? Like this. Yeah. So this is AX3E. It's asymmetrical. That means it's polar. We're not going to take it. HCl is polar. We're not going to take it. Directly, you see HF3. CHF3. This is what? This is AX4. Even though it appears to be a symmetrical shape, if you were to see all of the atoms, they're not the same. Since they're not all of the atoms are the same, what do we say? We say that it's gonna be what? It's gonna be polar, because not all of the atoms are the same. And what remains is this one over here. Anyways, if you do it, again, we need to draw it for the millionth time, the carbon dioxide. Anyways, if you did draw it, you would see that it goes here and it goes here. It has polar bonds, but it is a non-polar molecule. So we finished 20, we'll move on to 21. What does it say? Which contains only single bonds. Okay, this is from before. Single bonds means that it's saturated. Saturated means it's what? It's an alkane, right? Alkane means that it follows the structure CN, H2N plus 2. Which of the following follows the structure? Not this one, not this one, not this one. So B. B is the correct answer. 22. In solid methane, the forces between neighboring CH4 molecules are best characterized as CH4 molecules, and pay attention, between neighboring, not in the atom, between neighboring molecules, it's definitely LDF. Why? Because it's a hydrocarbon, right? Hydrocarbon. Anytime you see a hydrocarbon directly, it's what? It's non-polar, meaning it will not have dipole-dipole forces, meaning the only force that it will have is what? Is the LDF or the ID forces. 22 finished, we move on. So 23 to 25 contains 1 sigma and 2 pi. So we need to draw them all. B is what? This is B2. So B is group 3. Right, so let's do the Lewis structure. Boron is group 3. So it's 2 times 3, which is what? Which is 6. Minus already 2 electrons. 4 is left. So 1, 2, 3, 4. Boron, it's okay for it to be electron deficient. So this is what it's gonna look like, okay? So anyways, this is what it looks like. Then what do we have? Then we have N2. N2 is like this. N triple bond and directly. Now O2, if you draw it, it's like this. And then F2, if you draw it, it's like this. Now here they're telling us which of the following has 1 sigma and 2 pi. This has 1 sigma. This has 1 sigma, pi, pi. This is a possible option. 1 sigma, 1 pi, 1 sigma. So definitely the only option here is what is N2. The next one, they said which one has a bond order of 2. It means like which one has 2 bonds. It's definitely gonna be O2. Now, the last question, which has the largest bond association energy? Largest bond association energy needs to have what? The highest bond order, meaning the most number of bonds. Highest bond order. Which of them has the highest bond order? N2, because it has 3 bonds. Now, SO3 geometry. SO3. Okay, we start. S is in which group? S is in group 6 plus 3 times 6. Yeah. So 6 plus 3 times 6, that's going to be 24. Minus, already we used 6 electrons because we used 3 bond pairs. So 24 minus 6, that's going to be 18. Then 18 divided by 2, that's going to be 9. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now, definitely we cannot leave it like this. So what we will do in this scenario is we will erase one lone pair and we will turn it into a double bond. Why? Because we need the octet to be complete. Now that the octet is complete, what do we do in this scenario? We state the shape. This is gonna be AX3, right? And there's no electrons on the central atom because you take S as the central atom. So AX3, and this is what this is, a trigonal planar. Okay, so this over here is a trigonal planar. We'll move on to the next question, 27. Which of the following has a pyramidal shape? Pyramidal shape. So the only pyramidal shape we have is the trigonal pyramidal, right? And the trigonal pyramidal is always what? Is always AX3E. So basically we need to draw them and we need to find which one of them is AX3E. HBr is like this. H2S is like this. BH3 is like this. And then NH3 is like this. So definitely, which one is AX3E? It's the NH3. So that means NH3 has a pyramidal shape. We'll go on to 28. The hybridization of carbon atoms in the molecule. So you take one carbon and you count. I have 1, 2, 3, 4 surrounding. So this is the AX4. That means it's a tetrahedral. And the tetrahedral or AX4 has the sp3 hybridization. We'll move on to 29. Which of the following is most ionic? How do we find that? How do we find that out? We need to take the electronegativity. So just follow, right? Okay. And what you're gonna cancel out first is the non-metal with non-metal. So you will cancel out these because they're non-metal, non-metal. Okay. Now you're left with SiCl4 and CaCl2. Now Si, it is considered more of a non-metal than a metal, so that's why we will not consider it. So definitely the most ionic is gonna be a metal with a non-metal, which is CaCl2. Now 30, which of the following is the least polar? You need to follow this, right? So we have N with H, that's acceptable. Then we have H with F. Oh, definitely for sure. Oh, sorry, this is the most, my bad. They want the least polar. I chose the most polar, my bad. So HF is the most polar. Then OF, whoops, what happened? OF, and then IF. So you basically see which one is the closest to each other. It's definitely F and O. So that means OF is what is the least polar. We'll move on to 31. Pi bonding occurs in each of the following except. So basically you need to see which one of them does not have a double bond. So, or like a triple bond, and is like only single bond. So directly speaking, you know that only single bonds are what? Only single bonds are alkenes. And alkenes have a formula of CnH2n plus 2. So you're gonna see this no, this definitely not, and this is what this will be our answer because it's an alkane, right? An alkane has only single bonds. So if single bond is the only thing that we find, we will not have a pi. We will only have the sigma bonding. 32, which of the following has the shortest bond length? So we have to draw N triple bond N, O double bond O, Cl single bond Cl, and then I single bond I. Now, very important, the shortest bond length is usually the longest or the largest bond order. So out of all of these, the one with the longest bond order is gonna be what? It's gonna be N2 because it has 3 bonds. So now we'll move on to 33. The melting point of MgO is higher than that of NaF. Explanation for this observation include which of the following? First of all, Mg2 plus is more positively charged than Na. This is true. O2 minus is more negatively charged than F minus, yes, but O2 is not smaller than F minus. They're on, first of all, they're on the same period. Second of all, O is more is more negatively charged than F minus. What does this mean? This means that it has more electrons and thus it will have a bigger radius. So the only two correct are 1 and 2. Question 34, which has a zero dipole moment. You need to see which of these has a symmetrical shape. So HCN looks like this. SO2, what does it look like? SO2 looks like this. This is what SO2 looks like. Then NO2, what does it look like? NO2, it looks like this. N right? And then last but not least, we have PF5. PF5 looks like this. 1, 2, 3, 4, 5. So this is what PF5 looks like. Basically, you need to discover all of the structures from the central atom. So this is gonna be what? This is gonna be AX2, okay? This is gonna be AX2E. This is also AX2E, right? And this over here is AX5. So directly you remove the ones that have that are not symmetrical. So AX2E is not symmetrical. So now we're left with what? With AX2 and AX5. Now you check, is all the surrounding atoms the same? Here they are not the same, so this is definitely polar, so we will not take it. Here they are what? They are all the same, my bad. Here they are all the same, and since they are all the same, then they're gonna all cancel out, so the dipoles will cancel out, and this is gonna be what? This is gonna be non-polar. Okay, so that means the answer for this one is PF5. Now last but not least, which of the following is not planar? Okay, so let's draw each of these structures. We have CO3 minus, C, double bond O, 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 and then here's 2 minus. Now NO3 minus Lewis structure. It looks like this. N, O, 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 and this is gonna be minus. ClF3 Lewis structure. ClF3, it's like this. Cl, then F, 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 right? And then 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And then it has what? It has 2 electron pairs, 2 electron lone pairs. And then what do we have? And then we have PCl3. So it's like this. It's P, then Cl, 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 and then it has a lone pair over here. Okay, so which one of them is not planar? What do they mean by not planar? They mean, first of all, we need to describe their structure from the central atom. This over here is AX3. This over here as well is AX3. So both of them being AX3, they are what? They are trigonal planar. From the name, it is what? It is a planar. So definitely these two are out. Now, ClF3, it is T-shaped, but pay attention, it has some behind the plane, in front of the plane. What does it mean behind the plane and in front of the plane? That means there is a plane. So if there is a plane, you cross it out. Now, what's the last thing we have? It's this shape. Sorry, I forgot to name this shape. This shape is AX3E2, which is the T-shaped, okay? And it has behind the plane and in front of the plane. So that's why it is not, that's why it is planar. Now, last but not least, PCl3, which is our answer. It is what? It is a trigonal pyramidal, and it does not have anything behind the planar, nothing in front of the plane, right? Why? Because this is all 3D. So this is a 3D shape. This is not a 3D shape, the T shape. It's a planar shape, okay? So that means our correct answer is PCl3. That's it for today's video. Thank you guys for watching. I hope you enjoyed and have a wonderful